And in the last class, we were discussing about the probability, simple probability. Now we are discussing about the conditional probability, the section 3.6 in your textbook. So in this case, what we are doing, suppose we, by example, I am just explaining you what is the meaning of conditional probability. When two events are occurred and one having the okay, you are not able to see the tomorrow class, the calendar. Just a minute, I will also see. Hmm. Okay, I will see. But tomorrow, I believe it should be a regular class. No, this is a contact session 4. It's not 5. It's a contact session 4 only. Are you able to see the slide? Okay, fine. I will discuss with the concerned person. Tomorrow, it should be a regular class. Just a second. It's not preponed basically. Just wait. I will try to fix it. So tomorrow it should be a regular class also. This is a compensatory class. I will discuss with the concerned authority who are making the schedule for that. Okay, so don't worry about it. In the morning, you just check the calendar and you can find out the link for that. Okay, so this is the compulsory class. It is not a regular class, and tomorrow there will be a regular class here. Now come back to the course here. We were discussing about the conditional probability. So in the conditional probability, there are two events if we are talking about, and in the their events are depend upon the each other, then we can use the conditional probability. So one example we are taking here. Am I audible? Okay, fine. So suppose we toss a coin two times. One time it is one event, but if we are tossing a coin two times, so it may be a second event as well. Then the probability that we get two heads is 1/4. Simple, है ना? You know very well that it is become two head head, head tail, tail head, and tail tail. So this is the total sample space, and then probability of getting two heads is a 1/4 basically. Got it? But if we are just changing the concept and we are just saying here that suppose now that a coin is tossed two times, that it is the known that the one of the tosses yielding a head. Okay, so already one head. So that means what? These conditions we are applying, and then we are finding the probability of that both tosses gives the head. So at a time the sample space S1 is changed here, and it will become head head, head tail, and tail head. So at a time the probability will become 1/3. Mr. Vishnu, actually this time is three classes in a week, because we have just rescheduled the class on Monday of 26th January, and this time I am just taking the class because of compulsory class, because I have to complete the course within a due time, and I may be on leave later on. Okay, after some week I am on leave on Sunday, so you just revise on that Sunday specifically. So I have to take some compulsory classes. Otherwise, I am not able to complete the syllabus, and I am not able to define the 16 classes. You know very well that it is very... I can understand your problem, but you can also try to understand my problem, na? That I want to complete your syllabus within a due time. Otherwise, the quiz one is coming. Uh, it is timing approaching actually, and we are not able to cover the chapter 3 also. So it is very difficult for me and for you also to for the evaluation component. Okay, so now the possible outcomes are this one, and then we can say here that probability of coming so the second head is 1/3, and if you're not able to we are not able to shift to the weekdays. Second thing, that this is the only one option I had, so I have to do this one also. And if you are not able to cope up with this, so you just go for the recording also. Thank you, Mr. Sanjay. So nice of you. Now suppose we now define the event B as the event that the one of the tosses gives a head, and A as the event that both tosses are head. So it means what? We are just having the two events, and B event having the some effect on the for the event A. The probability that we get both times tosses had, given that is the important language which we are saying in the conditional probability, given that one of the tosses yield head is, so that is which we are saying probability of B is given 3/4, probability of A is given 1/4. That is the probability of A intersection B here. Okay, so 1/3 is equal to that is probability 1/3 is equal to 1/4 upon 1/3/4. So now what formula we are getting? Probability of A given B. This is the symbol we are using. Probability of A intersection B divided by probability of B here. Here we are trying to find out probability of B given A. Probability of B given A. So now we can say here probability of A intersection B divided by probability of A, where probability of B is not equal to 0 and probability of A is not equal to 0. Definitely, because it is already occurred. Okay. So now this is the condition which we are taking here, that the probability of B is equal to 3 by 4 and probability of A intersection B is equal to 1 by 4. So then it is become 1 by 3. So here by using the sample space, we are trying to find out this probability is 1 by 3. But in most of the cases, it's very difficult actually. So what we are doing, we are using this formula, probability of B given A is equal to probability of A intersection B upon probability of B. If probability of B definitely is not equal to 0, and you know very well probability of any event is never be negative, so probability of B is greater than 0. So probability of an event A, given that the probability of B has happened, we are talking about the probability in the relation of reduced sample space. So you can say that S1 is the reduced sample space of the S. We are taking the some condition specifically. Just give me a 1 second here. So we can just take one definition here. If A and B are two events associated with the random experiment, then we define the conditional probability of the event A given that B has happened. So B has already happened, already occurred. Now we are trying to find out the probability of A, and we can find out the impact of B on A specifically. Okay, by using the conditional probability. Now, general multiplication rule for probability is what we can just say here. Probability of A intersection B is equal to probability of A multiplied by probability of B given A, where probability of A is not equal to 0 here. Okay. So this is the formula here, as actually we are just using the formula here. Probability of A intersection B upon probability of B. We are given that probability of B is not equal to 0, and we multiplied it here. So probability of A intersection B is given as probability of A given B multiplied by probability of B, and we can say the probability of B is not equal to 0. So this is the second condition which I mentioned here. Okay. So this is known as the multiplication rule of the probability, that we can find out the probability of A intersection B in the form of conditional probability, that it is equal to the either probability of A multiplied by probability of B given A, or probability of B multiplied by probability of A given B here. So that is the conditional probability. Now we can say two events are known to be independent if and only if probability of A intersection B is equal to probability of A multiplied by probability of B here. Okay, so this is the concept which we are using here. So why we are just using this concept, that probability of A intersection B is equal to probability of A, and this is also be a probability of B given A. If we are saying it is probability of in this case, what we are doing, look, just a minute, I will show you that probability of A given B can be written as probability of A intersection B upon probability of B here. Okay, now this is independent event, so probability of A intersection B is what? Probability of A into probability of B, and it is probability of B, and it is cancel out. So probability of A given B is equal to the same as probability A. Okay, so there is no effect of B on A. So it means there are two independent events basically. So we can just say here in this case, the two events are called independent if A probability of A intersection B can be written as the product of the probability of A and probability of B. Now we are just going for an example. Two cards are drawn at random from a pack of 52 cards without replacement. Without replacement means what? We are just taking first and then second. Okay. So when we are just taking the second one, the first is with us. It is not with the pack. Okay, so find the probability that both cards drawn are A's. So what is we are taking here? Solution we are just taking, let A be the event that the first card drawn was an Ace and B be the event the second card drawn was an Ace. Here one Ace already drawn. Okay, so now we have the sample space, which is a reduced sample space, and accordingly we have to find out the different probability. So probability of A intersection B can be written as probability of A multiplied by probability of B given A. That we are saying that both cards drawn are A's here. So what we will say, probability of A, to find out the one A's, it is, there are 4 A's and total pack of 52. Okay. Now we are saying B given A. B given A is what? Already we are having the 51 cards because one card is already done. And one ace is also we have drawn. So only 3 ace we have. Okay. So that's why it is multiplied by 3 ace divided by 51 cards. So this probability of A intersection B is can be written as 1 upon 221 here. Okay, now this is the concept when we are talking about without replacement. If we are doing with replacement, so at the time again that ace is coming again, we can repeat it, and that will become 4 by 52 multiplied by 4 by 52. That is the probability of A multiplied by probability of B. Okay, and in that case here we are not having the value of 1 upon 221. It is a different value. Okay, so at the time they will become a, when we are talking about the with replacement, so at the time it will become independent events because there is no effect of the first event. Okay, so that is the concept which we are using here, that what if there are second events is occurring, what is the effect of the first event on the second event, that we are trying to find out the conditional probability. Okay, one more example we are taking here. An electronic system has two subsystems, A and B. It is known that. So information is provided to us. The probability of A phase is 0.2. So the yellow circle, the complete yellow circle is 0.2. B phase alone. B phase alone means what? The green circle except this one is 0.15, and probability when A and B fail. So both will fail means what? A intersection B fail is the 0.15. So we have to find out what do you want, Mr. Vishnu, in this case? The previous example. In the previous example, one ace we are collecting here. One ace we are collecting here. So what is the probability of draw of one ace? 4 ace total and divided by 52 cards. That is the probability which we have done. Okay. Now the second event we are talking about B. The B event having a without replacement. Without replacement means what? One card already with us. So total card in the pack is 51. And which card which we the card which we have, that is ace. So only we know that 3 A's are in the pack of cards. So what is the probability? The total number of A's in the pack is 3 and total number of cards in the that pack is 51. So what is the probability of getting A's from that pack of cards? It is 3 by 51. So it will become 3 by 51. But if it is not ace, we are not checking it is ace, so it will become 4 by 51 because we don't know which card we have. We are not checking it. Okay. Now come to the next question. Probability of A fails then given that B has failed. So how we can find out? Probability of B has failed. Firstly, we have to find out the probability B has failed. So how you can find out the probability B has failed? That B fails alone and A, B both are fails. Okay. So it means what? B fails means what? This plus 0.15 alone 0.15. So it is 0.30. Okay. Now we are finding the probability of A fails. Probability of A fails given B has failed. So probability of A intersection B by direct formula probability of B, and probability of A intersection B is given 0.15, 0.30. So it is 1 by 2 basically. Okay. Now you can find out the A fails alone. A fails. Most of the time we are just sticking for the two events only. But we are also mentioning here the total probability law when we are going for the n events. Okay, in a general formula, we are using the n events also. Now, B parts, you can find out A fails alone. How you can find out the probability of A fails alone? From the Venn diagram, you can say the probability of A fails alone is what? That is what? Probability of A minus probability of A intersection B. That you have already calculated. That probability of A is what? It is given as 0.2 and A intersection B which is given 0.15. So it is probability of A fails alone. Only this part, this. So what is this? But a complete yellow circle minus the combined one. Correct, Mr. Mahindra. Okay. So that is the way that by using the Venn diagram, we can find out the formula, what we have to calculate actually. So these are not a given formula. Okay. We can ask anything by using the Venn diagram. Now probability of B we are finding if we are just seeing that. So probability of B finding by using this part and this part. Similarly, we can just go for the another example and we are extending this theory which is known as the total probability law. And here we are taking about the n events. So we can say B1, B2, Bn are at, B and B1, B1, B2, Bn are n mutually exclusive and the complete yellow circle which is included the A intersection B as well. But A alone means what? That half yellow circle which is, we are removing the B part. So we can say that they are n mutually exclusive. You know very well about the mutually exclusive events, that they are not a common elements in that one. And exhaustive. Exhaustive events means what? When we are taking the union of these, then it will become completely sample space. Yes, we have to remove the that part of the yellow circle which is common in the B. We have to remove it. Okay. So events, then for any event A, probability of A can be written as probability of B1 multiplied by probability of A given B1, probability of B2, A given B2, and so on. For example, if we are just making this one, this is the complete sample space and we are dividing the sample space into the some events like n events. So this is like a B1 event, this is like a B2 event, this is like a B3 event, B4 event, B5 event, B6 event, B7, and so on. Okay, so n events. Now you can see I am just taking care of making these events that they are mutually exclusive. है ना? There are no elements common in that one. And when we are just taking the union for all, that is B1, union B2, union B3, union up to Bn, then it will become the complete sample space. So that is known as the exhaustive events. Okay. So how to find out the probability of then for any event A, that is by probability of B1 multiplied by this part actually. So we are just taking here event A just above it. Okay. So here A intersection B1, A intersection B2, A intersection B3, A intersection B4, A intersection B5, A intersection B6, A intersection B7, A intersection B8, and so on. So by using the general multiplication law, this is the formula. So we can find out the probability of A by using this formula. That is known as the total probability law. Okay, I will explain it again. This is a sample space. If I will write on the PPT now, so at the time it will just make a congested because I have to write something more in this one. So it is given in the slide. Don't worry about it. So we can say like this one, these are the event B1, this is event B2, B3, and so on up to the Bn. It is already added in this one. Okay, so B1, B2, B3, Bn, and now you can see here we are just making a one event A. So how to find out this probability of A? That is by using this, using this, using this and this one. How you can find out A intersection B1, A intersection B2, A intersection Bn. A intersection Bn is B1 is by the general multiplication rule is what? Probability of B1 multiplied by probability of A given B1 plus probability of A intersection B2, that is probability of B2 multiplied by probability of A given B2, and so on. Okay. So here we can say this is the complete sample space and we are dividing it into the n mutually exclusive and exhaustive events. Then we have another event after B1, B2, Bn, that is the event A. So how to find out the probability of A? That is by using the simple conditional probability law and general multiplication rule. Okay. So by using this, we can find out the probability of A. Now it's get it? So theorem on total probability law is what? A is the union of the mutually exclusive events. So that's why A intersection B1, A intersection B2, and A intersection Bn. We are trying to find out the probability of A given B1 is what? Probability of A given B1 is what? That we are trying to find out the probability of A when B1 has already occurred. Given that B1 has already occurred. So there's some more impact of event A of on the event A from the event B1 because B1 has already occurred. So that is the effect, having some effect on the event A. So the probability will change. The probability of A is not equal to the probability of A given B1. Okay, fine. So that just means what? A is given as the union of these events. So probability of A is given as intersection summation of these, which I already mentioned here. And A intersection B1 is given as the A intersection B is given as the probability of B1 multiplied by probability of A given B1 plus probability of B2 multiplied by probability of A given B2 plus and so on. Okay, plus probability of B1 multiplied by probability of A given Bn. Now we are just going on one example. In a certain assembly plant, three machines B1, B2, B3 make 30%, 45% and 25% of the products respectively. Okay, so it means what? Probability of B1, probability of B2 and probability of B3 is given here. That is 30%, 45% and 25% based on that chance. From the past experience, it is known that 2%, 3% and 2% of the product made by each machine respectively are defective. So made by the each machine means if we are just selecting that one. So it is by machine A. It is already occurred event, machine A, and we are finding, okay, they are defective. So it is given here, if we are just saying the probability of B1 is given as 0.3. Probability of B2, it is given as 0.45. Probability of B3, which is given as 0.25. Correct. Actually, I am just writing to explain it right now, but all information are already given in the slides. Just to explain it, that's why I'm writing here. Okay. And now what is information is given? A 2%. 2% means what? Probability of it is defective. If we are talking about the defective, so defective given B1, it is from first machine, it is 0.02. Probability of defective given B2, that is given 0.03. And probability when defective given B3, it is 0.02. Okay, of the product made by each machine respectively and are defective. Got it? Now a finished product is randomly selected. So it is randomly selected. What is the probability that it is defective? So what we have to find out? Probability of B we have to find out. Now you know very well how to find out by using the formula. So what we can say, that is the actually problem if we are writing on the slide. So it will just make a congested and you are not able to see what is written on that one. Let A be the event that the product is defective. Let X, Y, Z be the events that the product made by the B1, B2 and B3 respectively. So probability of X is 0.30, probability of Y is 0.45, probability of, sorry. Probability of Z is 0.25. So now you can see here, whatever I wrote on the slide, that is already given in the slide. Okay. Now what is given here? Probability of A given X is 0.02, A given Y is 0.03 and probability of A given Z is 0.02. Now we have to find out the probability of A. So probability of A, as I told you, probability of A is what? Probability of, here it is given X multiplied by probability of A given X. So all information is given for probability of Y multiply probability of A given Y plus probability of Z multiplied by probability of A given Z. By this formula, we can calculate this information. So probability of A is given by this formula and we substitute the values here and we are getting the answer 0.0245. So this is my request. Please solve this question and then verify the answer by your own. Okay. Thank you. Now it's clear. So directly you have to just plug in the values in the formula. Only the thing is you have to concentrate on the question what is given to us and what is asked. Okay. So what is given to us we can just write in this form. And now you can see after finding that what is given and what is asked, one formula you have to apply and just plug in the values and find out the answer. It's very simple. Okay, so don't worry about the so much calculations and all the things. And if you just do the practice, so that you also remember the formula for the closed book examination. Now we are just extending this concept here. Yes, yes, Mr. Vishnu. Yes, you tell me. Write it. So if the probabilities are 0.98, 0.986, and then 0.95, that a newly manufactured bottle of soap will be free of major defects, free of minor blemishing, and free of major defects and minor blemishings. Okay, so there are three things it is given here: free of major defects, free of minor blemish, and free of major defects and minor blemishes. Find out the probability that a bottle that is free of major defects will also be free of minor blemish. Okay, so solution is what? Machines are giving the fixed output, definitely, but here we are doing the quality check and we are not checking each and every. uh, After manufacturing, the person is checking all the items, but it will go for the another department for quality check. So they will not check each and every item. They are checking only some item, and based on that one they are making the probability. Let A be the event that the bottle is correct, Mr. Malay. Bottle is free of major defects, and B is the event of free of minor blemishes. So these are the two events we are talking about. Now probability of A is given 0.98, where probability of B is given 0.96, and probability of A intersection B is given as 0.95. So we have to find out, if you just see the question specifically, we have to find out the probability that is free of major defects will also be free of minor blemishes. So we have to find out the A in given B. Okay, that free of major defects, it is already given that it is a major defect, and what is the, it also be a minor blemishes. So for that we have to find out the probability of B given A. So by direct formula we can write it 0.95, that is the A intersection B upon 0.98 probability of A, that is 0.969 here. B part, probability of A given B. So by using the formula, the same formula, probability of A intersection B upon probability of B, it is 0.95 upon 0.96, it is 0.990. So by using the conditional probability, we can find out the given formula, or given answer here. Next example we are taking here: a consulting firm rents car from three agencies D, E, F. Okay, are the slides visible of the next example? 20% of the cars are rented from D, 20% from E, and the remaining 60% from F. So they are three mutually exclusive, because if they are rented from D, they are not rented from the E and F. So they are mutually exclusive events and exhaustive events, because they have to take the car from these these companies only. So 20 plus 20 plus 60%, that is the whole sample space of one. The probability is 100% chance. Okay. If 10% of the cars, so we can say the D, E, F, if we are making the events that it is rented from D, E, F respectively. So they are mutually exclusive and exhaustive events. Okay. Now 10% of cars rented from D, 12% cars rented from E, and 4% cars rented from F have bad tires. So this is the another event that the cars which we are taking the rent from rent, they have bad tires. Okay. So now we can say the probability of D is 0.20, probability of E is 0.20, and probability of F is 0.60. Now A is the event that it has a bad tire. So what is given here? 10%. So probability of A given D, that is coming from the D company. So it is 0.10, 10%. A given E is 12% and A given F is 0.04%. Now what we have to find out? Find the probability that a car rented from the consulting firm will have the bad tire. So what we have to find out? Have the bad tire, it is probability of A. So by using the total probability law, because D, E, F are the mutually exclusive and exhaustive events, so we can use the total probability law, and directly by total probability law we can find out the probability of A. Yes, you can find out the answer. So D, I am not writing the formula. I am writing here 0.20 multiplied by 0.10 plus 0.20 multiplied by 0.12. This is 0.12. Point is missing here. Plus 0.60 multiplied by 0.04. That is the formula to calculate that it has a back tire. Okay, so we can do the solution here, that it is a D, E, it is F, and now we can say here it is a back tire 0.10, back tire from E it is 0.12 and it is 0.04, and we can multiply it here like 0.0 multiplied by 0.2 multiplied by 0.1, 0.2 multiplied by 0.12, 0.6 multiplied by 0.04, and we are just adding it all and we are finding this value. Okay, I am just going slow because I am taking here so many questions here. Are you not getting? Okay, fine. Mr. Sanjeev, don't worry about it. Okay, I am waiting. Just go through it. Because it is a completely formula based question. That's why I am just saying that, okay, for different manner, we are just trying to cover up it. And according to the handout, you can see the handout, we are going very slow. In a handout, we have to move to the chapter 4. Yes, I will show you the question first. I am going slow according to the handout. If you see the handout right now, it should be covered in the chapter session 3 only. But actually I am going fast, little bit fast, definitely, because I have to do so many questions. I am not doing only one question and then move to the another chapter or another topic. Okay. Now it's clear, Miss Ria? So there is another way to find out the conditional probability, and then we can find out the probability of A very easily actually. Okay. Please do the question yourself. The slides are available and the recordings are also available. Now next topic is Bayes rule. Bayes rule is what? After finding the total probability law, so we are just okay, you will check, and if there is any other change, then you can just let me know. So in this case, after finding the total probability law, we are also finding the cause of that event. So that is what till now what we are finding. We are finding the probability of A. And what we know, we have the probability of A given B. Okay, that's we have that B1. Probability of A given B2. That's we have actually. That's why we now we are just finding the just opposite of that. We are trying to find out the probability of B1 given A. Probability of B1 given A. Okay, just opposite in that manner. So for that purpose, we required the Bayes rule, another formula. So we can find out the probability of BR given A is probability of BR. Simple example, probability of BR intersection A upon probability of A. Probability of A is what? It's a total probability law. And here BR intersection A, by general rule that BR multiplied by A given BR. Okay, so here Bayes rule is the same as we are applying the denominator, the total probability law, and in the numerator we are using the simple conditional probability law. Okay, so proof is what? Probability. I already done this proof in the by hand. So you are saying please send it as the edited slides. So again, it will just create the chaos in the when you are just reading it. Okay, that's why I'm not sending the edited PPT, because all information whatever I'm writing here, that is already available actually. Okay, so probability of BR given A is what? By using the conditional law, probability of A intersection BR upon probability of A. I am doing mathematics class. That's why I have to write it. I am not showing by the slides only. That's the problem actually. So you are thinking that we are writing different. No, I am not writing something different. It is already mentioned in the lab PPT. So don't worry about it. Okay. So now by the theorem on probability law, the probability of A we can find out by using the probability of total probability law. Okay, your answer is coming 0.068. So other students also check it. If it is coming different, then please let me know. Okay, after the class I will check. Probability of B2 multiplied by A given B2 and so on. Okay, fine, I will check and then I will correct it. Okay, and so on. So this is the probability of A. Now we are finding the probability of A given BR is what? Probability of A given BR multiplied by probability of BR by conditional probability, and this is the summation of the probability. The formula is given here. Okay, so that is the total probability law, and then we are using the Bayes theorem. Now come to the example here. Miss X is fond of seeing movies. The probability that she sees a movie on the day before the test is 0.7. By the Venn diagram, if you're just explaining it, actually it will like this one, this one, this one, this one. Okay, now this is the A. Now we are trying to find out this part, probability of B given A, just part this one. Okay, actually it should be a 3D diagram, then only you can explain, otherwise you will confuse in that case, because we are trying to find out by the shaded area is the same shaded area, but the first event, firstly we are making the box, and then we are making a circus event A. But here just opposite, we have to make the event A like this one, and then we can just say B1, B2, B3, Bn. Okay, so by the 3D diagram only you can explain this one, otherwise it's very difficult, because it is a timeline that first event A occurred or B1 occurred. Okay, so Miss X is fond of seeing movies. The probability that she sees a movie on a day before test is 0.7. Miss X is anyway good at studies also. The probability that she gets maximum marks in the test is 0.3 if she sees a movie on the day before the test. Okay, if she sees the movie or she doesn't see the movie. Okay, so there are two parts. See the movie and didn't see the movie. So that is a mutually exclusive and exhaustive events, definitely. And in that case, we are saying getting the maximum marks is 0.3. and corresponding probability is 0.8 before the test, and the corresponding probability is 0.8 if she doesn't see the movie. Okay, if Miss X got the maximum marks in the test, just opposite, she got the maximum marks. Find the probability that she saw a movie on the day before the test. Just opposite, we have to find out the probability. So what we have to do, we have to apply the Bayes theorem. Okay, because firstly they're seeing she is seeing the movie. Okay, and then next day they are just going for the exam. Okay, but now we are trying to find out this opposite probability that we have already mentioned that okay, she got the maximum marks. Now just explain the probability that she saw a movie on the day before the test. Okay, so that's why we are using the Bayes theorem. So now firstly we define the events properly. So let B1 be the event that Miss X saw the movie on the day before the test. Okay, B1 and B2 be the complementary event that she didn't see the movie on the day before the exam. Is it clear to all of you? So there are two, B1 and B2 are mutually exclusive and exhaustive events. Okay, she saw the movie and she didn't saw the movie. Got it? Next is, let A be the event that she got a maximum marks in the test. Okay, so in the next day they wrote the test and she got the maximum marks. She got the maximum marks in the test. Thus, we want probability of B1 given A that we are finding, and by using the Bayes theorem, this formula is probability of A intersection B1 and divided by probability of A. Now, can you tell me how we can find out the probability of A? Probability of A intersection B1 by the conditional probability of B1 multiplied by probability of A given B1 and probability of A. Just tell me what is the probability of A. If we just draw the diagram, there are two parts, B1 and B2. Okay, this is the event and maximum marks. So probability of A is what? Probability of A given B1 multiplied by probability of B1 plus probability of A given B2 multiplied by probability of B2. All information you have, just plug in the values in the formula. What is the probability of A given B1 multiplied by probability of B1? If you just go back in the formula, this one. So the probability that she saw a movie, it is B1 0.7 and then B2, probability of B2 is 0.3. Okay, and the probability that she maximum marks when she saw a movie, so A given B1 is 0.3. So you can see here it is already mentioned in the slide, 0.7 multiplied by 0.3. So here you can say here 0.7 multiplied by 0.3 plus B2 is what? 0.3 multiplied by 0.8. Okay, so this is the probability of A that is given here. And then probability of B1 multiplied by probability of A given B1, 0.7 multiplied by 0.3 is this. So this is the Bayes theorem. In the Bayes theorem, in the denominator, we are using the total probability law, and in the numerator, we are using the specific probability here. It depends upon the what information is given, and they are asking just opposite information. You can see the question. From the question itself, it is mentioned here. What is given? The probability that she gets the maximum marks in the test if she saw a movie. Okay, and what they are asking, that got the maximum marks, find the probability that she saw a movie. Okay, just opposite of it, then we can apply the Bayes theorem here. Okay, any query? So I'm just taking a break and then I will start. Mr. Raksha, actually, in the open book examination also, you are not allowed to take any type of handwritten notes and print out of the slides. Okay, so you have to just make your notes your own by you not making the notes. I can say that you can just go through the book, that which formula is given in your book actually. And here in the, when you are just doing the practice only, then you can make the formula notes by your own. Otherwise I will provide you the notes formula, then what it will work. So till now, I just summarized till now. We have done the only the two parts, three parts basically. Firstly, I mentioned is this conditional probability. So it is probability of A given B. It is what? Probability of A intersection B upon probability of B, provided probability of B is greater than 0. And all things are based on this formula only. Then we are using the total probability law. In this one, we can use the probability of A is as probability of BA given B1 multiplied by probability of B1 plus probability of A given B2 multiplied by probability of B2, 1 minute, plus and so on. This is total probability law, and in this case we are just using here that B1, B2, Bn are the mutually exclusive and exhaustive events. After that we are defining the Bayes theorem. What is the Bayes theorem? We have to find out the probability of B1 given A. So we are using the same probability of B1 intersection A upon probability of A. So by probability of A, we can find out by the total probability law. And the numerator is coming here, probability of A given B1 multiplied by probability of B1, which is given information and probability of A by using the total probability law. These are the three things we have done till now. Okay. So I'm just taking a 5 minutes break and then I will come back. So if you want, I will give you the question here. You just go through the question and just trying to find out the answer. Okay, in between. Thank you. Thank you so much. I'm just taking a 5 minutes break and then I will start the new chapter after that. Welcome you back after the break. So I started a new chapter, chapter 4, probability distribution. So till now we have done about the probability. Now we are discussing about the probability distribution. So am I audible to all of you? Slides are visible. Thank you, thank you, thank you so much. So now we are starting a chapter 4, that is the probability distribution. That means what? We are defining the random variable which are just like a events. Okay. So you have done the, in chapter 3, we have done the events, and then we are trying to find out the probability of that events. Okay, now here we are just converting these events, or we quantize in that events in the random variable, and then we are trying to find out the probability of that random variable. Okay, same concept but in a different manner. Got it? Second thing is, what we will do, we just identify for a particular experiment, particular type of experiment, and particular type of a random variable, if they follow some specific properties, they satisfy the specific properties, then we can say okay, it follows the particular distribution, and then there is no need to calculate the formulas. Already calculated formulas are available, and we can just apply the formulas. So it will become a formula based mathematics, not so much calculation we are doing, only plug in the values in the formula. For example, in the Bayes theorem also you can see the direct formula you are applying, that okay, what information it is given, and what is asked, based on that we can apply the Bayes theorem. This is the Bayes theorem, and we plug in the values, okay, in the formula only. Same here we will do to find out the different type of probabilities of random variables. So we can just identify that which distribution is this, and based on that we directly apply the formula and calculate the required probabilities. Okay, so that will become more easier to calculate the different type of probabilities if we just identify the some properties. Okay, so that's we are doing in the probability distribution. So firstly we will do the general method to calculate the formula. Okay, how we can derive the formula, what are the basic formula, and after that we will go for the specific distribution. One by one we are doing it. Okay, so now the first is, as I told you, random variables. So here we are not dealing with the events. The events we are just converting into the random variable. So we are just taking here, suppose we are taking the EB, a random experiment. Suppose to each outcome S, we associate a real number XS. Okay, and we can say it is a random variable. For example, if we are tossing a coin, there are two possible outcomes only, that is we say head and tail. Okay, so instead of head and tail, what we will say, this we quantize it. We quantize it means we are just giving a real number. So we are saying okay, head is coming as 0 and tail we consider as 1. So sample space, we are not saying head and tail, we are saying it is 0 and 1, either success or failure, like this one. Okay, success is 1 and failure is 0. So we just accordingly the experiment we set the things here. Okay, for example, so many example we have taken for the cards, playing cards. So in that one 52 cards are there, but you know very well it is a k q queen, that is the ace, that is the king, that is a queen, and that J. So they are not, the number is given. So what we will do, we are just giving is 11 number, 12 number, 13 number, and this is 1, because that will start from 2 to 10, the numbering of the playing card. Okay, so we are just adding here these 4 number also. Okay, so in this one, that is sample space is become here for 4, that is 1 to 13, and for different for 1 to 13, 1 to 13, and again 1 to 13. Okay, so that will become here 52 cards. So at the time we are not quantize it, we just quantize the value here. We are not using ace, king, queen, and J. Okay, so that is the concept which we are using here. So the random variable basically is any function that assigns a numerical value actually to each possible outcome. So whatever the each possible outcome, if it is a numerical value, for example, rolling a dice. So rolling a dice specifically, so it is like a rolling a dice when we are doing. So it is 1, 2, 3, 4, 5, 6 already quantitized. But tossing a coin, it is not able to quantize. 2 to 10 in the playing card, it's quantitized, but we can just use the A, K, Q, J. They we can't quantize. So we are trying to quantize them also, and we can just give a numerical value for that. So that is the concept of the random variable basically. Okay, I already gave you the two examples, but again we are taking more examples. So let us toss a fair coin twice, 2 times. So sample space is TT, TH, HT, HH. So what we can say, we can just take a random number. X of TT is equal to 0, means no head. But X of TH and THT 1, and H of HH is 2. So what is the function here? That is the number of heads are coming. Total number of heads are coming out of 2 tossing. So that is become a random variable value. So here it is 0, 1 and 2. So one head, it is 1, and TT is 0 and 2. So all possible outcomes are these 4, and we are just quantize them according to our requirement. Okay, that is the random variable. So we defined a random variable X that counts the number of heads obtained when we toss a fair coin 2 times. Okay, so it depends upon to us that what type of random variable definition we have to mention. Okay, for example, the events also. If you done in the last class, that's last chapter, in that one, it is up to us that how we can define the events properly. Okay, same here we are doing it. Don't worry, we will do it so many times. Okay, I'm just giving the example, then only you can understand it better. Roll a pair of balanced die. Okay, where the sample space consists of 36 ordered pair ij. So I is equal to 1 to 6, j is equal to 1 to 6. Okay, now we define xij is the summation of these, whatever that addition is coming here. 2 die we are just rolling, and whatever the values are coming in the on the top, we are adding them. So that is the xij. Okay, can you tell me the all possible value of xij if we're just defining it? So I will just show you the sample space. So I believe that everyone make a sample space. We have already done it. It is 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, 2 1, 2 2, 2 3, 2 4, 2 6, 2 7, 2 8, and so on up to the 6 6. So total 36 possible options. Okay, now we are saying xij is I plus j. So xij will start from, it is start from 2 because first entry is coming 2, then 3, then 4, then 5, then 6, then 7. 3, 4, 5, 6, 7, 8, 9. Okay, similarly, sorry, here it is wrong. Here it will become 3 1, 3 2, 3 3, 3 4, 3 5, 3 6, and then again we can start from 4 1 and so on. Thank you, Mr. Sanjeev. Okay, yes, 2728 will not be there definitely. So x will start from 2, and that will go maximum up to what? 2 3 4 5 6 7 8 9 10 11 12. So x is equal to 2 3 4 5 6 7 8 9 and 10 and 11 and 12. Okay, so this is the possible values of x, that is the summation of xij. So we are defining this random variable. Got it? If we are saying here another event, accordingly we can change the values of x. Oh, okay, if we are not taking here summation, we are taking the multiplication. Let us suppose y I am just giving you this one more example. We are taking y. Y is the I multiplied by j. So that y is starting from what? It will start from 1. Okay, 1 multiplied by 1 multiplied by 1, 2 up to what? Can you tell me? 36. Okay, so maybe all values 1 to 36 will not come, because here it is 1, it is coming 2, it is coming 3, 4, 5, 6, and it is 2, 4, then 6, then 8, then 12, and so on. Okay, so we have to check that what is the definition of random variable here. So here xij is equal to I plus j. We are taking here this example I mentioned here. So example, thus we are saying 2 and comma 4. So this value is coming 6. Like x comma I plus j is equal to 3 comma 4. It is coming 7, and so on. So x's values are varying from 2 to 12. Total values are 2 to 12. Now can you find out the probability when x is equal to 2? How you can find out? You know very well. 2 is possible only in one case, 1, 1. Otherwise, it is not possible. So it means what? Only one favorable case. Total favorable case is what? 36. Total cases are 36. So 1 by 36. Okay. So that's the method we can find out the probability. Can you find out the probability when x is equal to 3? 3 in coming in which cases? 1, 2 and 2, 1. Only these two cases only we are getting the 3. So it has become 2 by 36, and so on. Okay. So random variable, correct, Mr. Vishnu. So here we are taking the random variable different according to the definition, what we required actually. Okay. So discrete random variable we are just talking about here. That is means all examples we are talking about the random variable discrete. So now you can see here there are two type of a random variable, discrete and continuous. Okay, so discrete means where the sample space is discrete, means it is a simple finite set, or uncountable or countable in infinite set. Then it is talking about the discrete number of persons, number of values. Here we are saying here tossing a coin. Okay, all are discrete. But if we are talking about the distance, so it means a continuous. Okay, if we are talking about the time, so it is also a continuous. Clear? If we are talking about the length, so it is also continuous. So if a random variable which we are defining in the form of distance, you can say the mass, the weight, or you can say the length. So these are continuous. So sample space is also become a continuous random continuous sample space, and then we can make a random variable as continuous. We will take the example. Don't worry about it. Okay. So let us toss a fair coin till we get a head. We are tossing a coin so many times. First time, if it is we are getting head, then okay. Then first tail, then second head is this. First tail, second tail, and then head. And then we are going up to the infinite times when we are getting, we stop it when it is head. One type of example that we have already done. Do you remember it? That is the finite values we are talking about. But here we are talking about the infinite times. Do you remember? We are just hitting a missile. Hit or miss. If it is a miss, then again second missile. Hit or miss. Again third missile if it is a miss in the second, and so on. But at the time we have only 5 missiles. But here we have a coin and we are tossing until we are getting the head. That is the difference only. Okay. So xh is equal to 1. Xth is equal to 1. Xtth is equal to 3. Xttth is equal to 4. This should be 4. Okay. Means what? How many times we are doing the, we are tossing the coin. Okay, that is the random variable. So we have defined a random variable as that counts the number of tosses needed to get the first head. How many times we have to toss to get the first head. Got it? So that concept which we are using here. In this case, range of x is what? Set of values assumed by x is either finite or countable infinite. So that set we are talking about, it should be infinite, but it should be countable. So at a time we can just go up to the infinity, but we can stop somewhere else. Okay, so that's why it is known as the countable infinite. There is a specific definition of countable infinite in the mathematics, but we are not going in that area. We are just saying here it is a countable infinite. Then we can say this set is, this random variable is discrete here. Okay, so this is a discrete random variable basically. Okay, otherwise it is a continuous random variable. I already told you the example of the continuous random variable and the discrete random variable. So probability distribution is what? That is the, we toss a fair coin 2 times. All things I am just trying to explain by the example only. Okay, suppose we toss a fair coin 2 times. Let x be the random variable that counts the number of heads got. Okay, only 2 times. So how you can just find out the number of heads got? Total sample space is head, 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 tail, tail, head. We have already done tail, tail. Okay, x is the number of that counts the number of head. So it is 2. For this it's 1. For this is 0. So x is 0, 1 and 2. 0, 1 and 2. Clear? Now we can find out the probability of this random variable x is equal to 0. Probability of getting no heads. What is the answer? I believe that everyone knows. So many times we have done. Yes, please write it in the answer. Probability, probability. 1 by 3. Why it is 1 by 3? It is 1 by 4. Why it is 1 by 3? It is 1 by 4. It is total elements in the sample space is 4. And we have only one option, that is x is equal to 0 is 1. So it is, the probability is 1 by 4 here. Now probability of x is equal to 1. Yes. There are two options, this and this. So it is 1 by 4 plus 1 by 4. 2 by 4, correct. So it is 2 by 4. Probability when x is equal to 2. 2 by 4. Why it is 2 by 4, Mr. Akshay? Why, Mr. Mahindra, it is 1 by 2? It is 1 by 4. Mr. Sanjeev, why it is 1? Probability, I am asking probability. Mr. Vineet, why it is 3 by 4? Only one option when x is equal to 2. So it is 1 and the total value is 4. Mr. Vineet, please check. Mr. Mahindra, please check. Okay, it is 1 by 4. So that is the way to calculate the probability when in the terms of random variable. We are not changing the probability. We are just changing the way of representation. We are not defining the events. We are defining the random variable. That is the only thing. X is what? Mr. Rudresh, what is X? X is the number of head. So HT and TH, in both cases, number of head is 1. Okay, count the number of heads. Clear? So it is a simple example. Don't be confused here. You can find out this probability. Only we are not taking the event. We are not writing the event. We are just writing the value of random variable that are varying from 0, 1 and 2 only. Okay, and how to find out the probability. So this is known as the, we can write it in the probability tabular form. So how we can write in the tabular form? K 0, 1 by 4, 1, 1 by 2, and then it is means what, 2 by 4, and 2, 1 by 4. Okay, so this table is known as the probability distribution of a random variable x, and x's definition is, yes, number of heads in first option is 2, so it is 2, and I wrote it here 2, here I wrote it is 1, and it is 0, so there are these three options only. X is 2, it is not 2 by 4. How many times is this coming, head HH? What is the probability of getting HH, Mr. Sanjeev? Leave X. What is the probability then X? Okay, this is the value 2 of random variable. But how we can find out this H is the probability of HH? Is 1. One time it is appear, and 4 times we can say. HT and TH 2 times is coming, so 1 by 4, 1 by 4. And this is 1 by 4. It's not 2 by 4. How many times the number of head is coming 0? One time. So that's why it is 1 by 4. In all 4 cases, this is 1 by 4, 1 by 4, 1 by 4, 1 by 4. Okay. Now, but these are the two random variables having the same value, 1. So that's why we can say here it is 1 by 4 plus 1 by 4. So this is known as the probability distribution of a random variable x. Got it? So this table we have to find out. Now come to the definition. When we are rolling a dice, so a probability distribution of a random variable x that gives the sum of two numbers on the top. Okay, two numbers on the top. Same example we have done xij. So I plus j. We are taking the sum of the two numbers on the top. So I already told you what are the information. X values varying from 2, 3, 4, 5, 6 up to 36. No, sorry, up to the 12. So it is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now we have to find out the probability. I will show you the sample space. This is the sample space which we have already made, and we have already calculated the probability when x is equal to 2. Only one time it is coming 2. That is 1, 1. So it is 1 by 36. X is equal to 3. How we can get? Only 2 times. 1, 2 and 2, 1. So 2 by 36. So 1 by 36, 2 by 36, 3 by 36, 4 by 36, and so on. We are getting the probability. So probability when x is equal to k, you can find out easily, and that is known as the probability distribution. Got it? So whatever you have done in chapter 3, find out the probability, same thing we are doing here. No change at all. What we are doing? We are not doing anything here in the PPT. I wrote it here, 2 by 36. It is already written here. I wrote probability x is equal to 2 is 1 by 36. It is given here. Okay. So this is just for explanation only. Everything is clear. So we are coming to the mathematical definition. This is a discrete type because we are taking the addition of two numbers. It is always be a discrete. Discrete number addition, then discuss. Sorry. So now come to the formula. because this is by example I am saying. So example, the formula is saying, or the definition is, the probability distribution of a discrete random variable x is a list of possible values of x together with their probabilities. So what is the probability here? So fx is called the density function. For x, the probability distribution satisfies, there are two properties. If a function satisfies these properties, then we can say it is a probability density function of a random variable. Got it? So first is, it is always between 0 and 1. Why? Can you explain it? We have done the completed the chapter 3. Now can you tell me why we are saying it is between 0 and 1? Definitely it is not been the percentage. Correct. Correct, Mr. Vishnu. No, it is not pass or fail. It is not the case of the pass and fail. It is a probability. By the definition, fx is any probability, and probability of any event of any random variable always between 0 and 1. Okay, it may be, it is not 0 and 1. We are saying it is between 0 and 1. Probability of that mass function, you have already done it. Density is 0.3, 0.5, 0.6, whatever it is. Okay, that is the first case. Second is the summation for all probabilities for all possible values of x. It is always be 1. Okay, so when we are just seeing the previous question, you just add this one. It should be 1. If you are just going for the another example, this you are adding these all values, it should be equal to 1. Otherwise, it is not a probability density function. Okay. Because if you remember, we have done axioms of the probability. So what are the axiom? Probability of any event is always be greater than equal to 0. Second axiom is what? Probability of sample space is 1. So x having all values, and that values are always equal to, when we are taking care of all values, then is defining the sample space total. Okay. So that's why these axioms are the defining in terms of the probability density function. So probability density function is what? It is always between 0 and 1. When we are taking all possible values of x, summation of it, that's adding of it is equal to 1 here. Okay. And probability distribution is what? The probability density function is what? It is the probability when x is equal to small x. Small x is what? Observed value. Okay, so capital X is the random variable and its observed value means probability when x is equal to 2. So small x is what? 2. Probability when x is equal to 8. So it is small values of x is what? 8 here. Got it? Next is concept is cumulative distribution function. So cumulative distribution function is denoted by the capital Fx, and we are adding till that point the probability when x is less than equal to small x. Okay, so we add the probabilities till that point. That is known as the cumulative distribution function. Okay, means what? We are just finding here till now one point, x is equal to 2, x is equal to 3. Now I am just finding probability when x is less than equal to 4. How you will do it? When x is equal to 2 plus x is equal to 3 plus x is equal to 4. Got it? Less than equal to 4. That is the f of 4. The CDF. The cumulative distribution function. What is the formula here? Let x be a discrete random variable with values x1, x2 arranged in the increasing order. Okay, 0, 1, 2, 3, 4, 5, whatever the order, we are just maintaining in the increasing order. X1 is less than x2 is less than s. Then for any real number x, we can define the CDF. That is probability cumulative distribution function. Okay, so terminology we are using here, cumulative distribution function. So fx is called the cumulative distribution function CDF of the random variable x. Okay, and fx represent the sum of all probabilities of the values less than or equal to that point that x can take. Okay, clear? So if we are saying in the previous example, yes, in this example, can you tell me the probability when x is less than equal to 5? How you can do it? So that is what? Probability when x is equal to 2 plus probability when x is equal to 3 plus probability when x is equal to 4 plus probability when x is equal to 5. Okay, so it is 1 by 36 plus 2 by 36 plus 3 by 36 plus 4 by 36. So we are adding it and we are getting the value 10 by 36. That is the f of 5. Clear? Don't be confused. Just addition. That is the CDF. So if you know the random variable, if you know the probability distribution function, you can find out easily by addition the cumulative distribution function. Yes, I'm writing in the fraction form 10 by 36, which is easier to explain actually. Okay. Similarly, we can find out different values here. Properties of fx, I will take some example also, don't worry about it. Okay, I gave you the one example, but more example on the slides I will show you. The properties of CDF, PDF we have done. Probability density function, what is that? 0 is less than fx is less than equal to 1. This is small f and that is capital F. Okay, and summation for all fx is equal to 1. These are the properties of density function. The properties of CDF, cumulative distribution function, is it is always between 0 and 1. Okay, again, but probability of minus infinity is 0 and probability of plus infinity is 1. So it is going from 0 to 1 only. And it is an increasing function. Always increase. If your value of x will increase, then fx will also increase here. Because we are adding some more. Okay. Probability when x is equal to xi is what? Probability of xi minus f of xi, just before it. Because at the time we are adding, so when we are just doing the opposite calculation, so we have to subtract it. Okay, we are taking one example here. X is a random variable that counts the number of heads got when a fair coin is tossed twice. Same example we have done. Do you remember? So here x is equal to what? 0, 1 and 2. Fx we are defining here 1 by 4, 2 by 4, 1 by 4. That you have done. Clear? Now we are saying here fx is equal to 0 when x is less than 0. X is start from 0. So it is less than 0, it is 0. But as we reach at 0, so it will become 1 by 4. Okay. So it is become 1 by 4 and till 1. In this range, it is completely 1 by 4. When we had reached to 1, so it will become 2 by 4. Okay. So it is what? Fx is equal to 3 by 4. 2 by 4 plus 1 by 4. 3 by 4 in between 1 to 2. Okay. And at 1, it is 3 by 4. Next, fx is equal to 1 when x is greater than equal to 2. So all values we have to define in a complete range here. Okay. So we can say like this one, I just make a graph here. It will start from 0. This is 1, this is 2. 0, 1 and 2. So before it, I will just, this is 0. Now at 0, it will become 1 by 4 and it is 1. And just at exactly 0.1, it has become 3 by 4 and then this one is 1. So it is 1, 3 by 4 and 1 by 4. Okay. So it is from minus infinity, it is 0 and it is going up to the plus infinity for 1 here. That is the cumulative distribution function. Okay. And here you can also define, you can find out f of 1.5. What is it? It is 1.5 is coming in the second range. So it is 3 by 4. Okay. But the small f of 1.5 is what? It is coming in this range. So it is 0. It is exist at 1 point only. The probabilities exist at 1 point only. But the cumulative distribution function exists for all range. It is a function which is defined in the minus infinity to plus infinity here. Okay. One more example. A certain gas station has 6 pumps. Let X denote the number of pumps that are in use at particular time of day. Okay, they are not using all times. Suppose the probability distribution of X is given as here 0, 1, 2, 3, 4, 5, 6. Probability density function is already given. So what you can verify, is it a probability density function or not? How you can do it? All values are greater than equal to 0, and when we are taking summation, it should be equal to 1. Clear? This is a probability density function, probability distribution. Now question is, find the probability that at most 2 pumps are in use. Okay, Mr. Vishnu. Okay, fine, fine. So I will upload the slides here. I have the 2-3 questions more. So that we will discuss in the tomorrow's class. Don't worry. Okay. Na? And please go through it. I will upload it. So I have this question and this one more problem. And then that we will start the new part, that is the binomial distribution. Okay. So in the next class, we will discuss these 2 questions. And then we can move ahead here. Okay. Thank you. Thank you so much. Yes, I will upload it today only. After 5 minutes, I will upload it. Thank you. Thank you all for your patience, for your cooperation. Thank you. Thank you so much. Okay. So we will meet tomorrow in the regular class. Thank you. Thank you so much. But please go through these slides. Yes, tomorrow there will be class. So please go through the slides. Whatever the information is provided to you, please do it so that you can understand